Okay, class, we're about to start section 3.5, dividing fractions and mixed numbers. Section A, finding reciprocals of fractions. In order to divide fractions, we must know how to find the reciprocal of a fraction or a whole number. The reciprocal of a fraction. Two numbers are reciprocals of each other if their product is 1. The reciprocal of the fraction a over b is b over a, because a over b times b over a is equal to a times b all over b times a, which is 1. Finding the reciprocal of a fraction. To find the reciprocal of a fraction, interchange its numerator and denominator. Okay, now, besides all of this definition, simply put, it's just basically like this here. Whenever you have a fraction, all you have to do is flip it. That's called the multiplicative inverse, but the actual action is that you're flipping the fraction. So let's take number 1 down here. 4/9 becomes 9/4. So that is our final answer. The reciprocal of 15 over 7 is 7 over 15. Now we look here at number 3. We have 9. 9 is really 9 over 1, and the reciprocal of 9 over 1 is 1 over 9. Now we look here at number 4. The reciprocal of 1 over 8 is 8 over 1, but we never leave our final answer over 1. So 8 over 1 is just 8. Now we go down here to section B, dividing fractions. We use reciprocals to divide fractions. To divide two fractions, multiply the first fraction by the reciprocal of the second fraction. If a, b, c, and d represent numbers, and b, c, and d are not 0, then a over b divided by c over d is equal to a over b times d over c. And then we multiply those values. Okay, now, this is how we're going to do this. I'm going to have you take a look at this problem here. We have 3/4 divided by 1/8. So the first thing that happens is this first fraction stays the same. So 3/4 stays the same. I'm going to write this over to the side. I know you all can see this here, but I want to show you what I'm going to do. I'm going to write this over here. 3/4 divided by 1/8. Okay, the first thing is this 3/4 stays the same. So this first value here always stays the same. Division becomes multiplication. That's your next step. And then the second fraction, you take the reciprocal of the second fraction, which here would be 8 over 1. Now remember, I told you, your final answer cannot be divided by 1, but we're not done yet. So we can leave it divided by 1 to solve this problem. Now let's do the prime factorization like we did in previous problems. 3 is already prime, and we know the prime factorization of 8 is 3 2's multiplied by each other. Now we take the prime factorization of 4, which is 2 times 2, and since that's multiplied by 1, we just leave 2 times 2. We add 2 sets of 2's that simplify out, and this will give us 6 over 1, and 6 divided by 1, we know is 6. So our final answer is 6, just like they have here. Now we will use the same process when we come down here to number 1. Remember, this first fraction stays the same. Division becomes multiplication, and we take the reciprocal of the second fraction. Now, we do the prime factorization. 3 is prime, and 5 is prime. Now we do the denominators. 2 is already prime, and 14, we know prime factorization is 2 times 7. Now, if you notice, they have nothing in common, so we would just multiply. 3 times 5 is 15. 2 times 2 is 4 times 7 is 28. So our final answer here is 15 over 28. Now we go to number 2. So we will have 8 over 7. Division becomes multiplication, and we take the reciprocal of the second fraction. Now we simplify. We know 8 prime factorization is 3 2's multiplied by each other, and 9's prime factorization is 3 times 3. Now 7 is already prime, and 2 is prime. Now these 2's simplify out, and what we're left with is 2 times 2 is 4, times 3 is 12, times 3 is 36, all over 7. Now, since we're not dealing with mixed numbers yet, we would just leave it as 36 over 7. Now we come here to number 3. Same process. This first fraction stays the same. Division becomes multiplication, and we take the reciprocal of the second fraction. Now the prime factorization of 4 is 2 times 2, and then we multiply it by that third 2 here. Prime factorization of 9 is 3 times 3, and since it's times 1, we'll just leave it 3 times 3. They have nothing in common, so your numerator is 8, your denominator is 9. Now we go here to number 4. 6 over 9 stays 6 over 9. Division becomes multiplication, and we flip or take the reciprocal of the second fraction. Now 6, we could take the prime factorization of 6, which is 2 times 3, and then times 3. All over. 9 is 3 times 3, and 8 we know breaks down to 2 times 2 times 2. Now we simplify this out. We have one set of 2's that are in common, and we have 2 sets of 3's that are in common. Now remember, I told you all before that if everything simplifies out in the numerator, it becomes 1, or even in the denominator as well. Now in our denominator, we had 2 2's left, so 2 times 2 is 4, and our answer is 1/4. Now we scroll down here to number 5. Now, we have a positive divided by a negative, so we know our final answer is going to be negative. So we could put equals a negative. We could put that over here. But below here, let's write this out. 16 over 27 stays 16 over 27. Division becomes multiplication, and then we take the reciprocal of this factor here. So we'll put 15 over 8. We don't need to put the negative sign because we have it here. We know our final answer is going to be negative. Now we take the prime factorization. Prime factorization of 16. We know it's 4 2's. And the prime factorization of 15 is 3 and 5. Now in our denominator, 27, prime factorization is 3 3's. And 8, the prime factorization is 3 2's. Now we simplify out what they have in common. We have one set of 3's, and then here we have 3 sets of 2's that we can simplify out. Okay, now when we multiply, 2 times 5 is 10, and 3 times 3 is 9. So our final answer would be a negative 10/9. Okay, now we go here to problem number 6. Now again, we take this first fraction, keep it the same. Change division to multiplication, and take the reciprocal of the second fraction. Now, we can take the prime factorization. Now I say take the prime factorization of the numbers first. So the prime factorization of 21 is 3 times 7. The prime factorization of 25 is 5 times 5. Now we do the variables. We add x squared, so we'll do x times x, and we have only y, so we'll bring that y here. Now we look at the denominator. The prime factorization of 10 is 2 times 5. The prime factorization of 14 is 2 times 7. And then we will have 1x and also our y. Now let's see what we can simplify out. We have one set of 5's in common, and we have one set of 7's in common. And then the variables, we have one set of x's, one set of y's. Now we look here in our numerator, we have 3 times 5 is 15 times x is 15x. And our denominator, 2 times 2 is 4. So it'll be 15x over 4. And that's it. Now it says here, when dividing fractions, do not look for common factors to divide out until you rewrite the division as multiplication, which we did. Now, dividing fractions and mixed numbers or whole numbers. Now listen, we will follow the same process we did when we did the multiplication of mixed numbers and whole numbers. Whenever you're dealing with fractions, you must change any mixed number or whole number and make it into an improper fraction. So before we even change this to multiplication everything, we would make this 7 over 1. So this first fraction would stay the same. Division would become multiplication, and the reciprocal of 7 over 1 is 1 over 7. Now 4 breaks down to 2 times 2, and 9 is 3 times 3, and 7 is already prime. So our final answer here is 4 over 63. Now we go here to number 2. Now we have to change this 3 4/5 into an improper fraction. So we'll leave this 8/15 divided by, our denominator would stay 5. 3 times 5 is 15, plus 4 is 19. So now we will have 8 over 15 times 5 over 19. Now we do the prime factorization. Prime factorization of 8 is 3 2's, and we also bring over our 5, which is prime. 15's prime factorization is 3 times 5, and 19 is already prime. The only thing we have in common is one set of 5's. 2 times 2 times 2 is 8, and 3 times 19 is 57. So our final answer is 8 over 57. Now we scroll down here to number 3. We have to find the improper fraction, and we know our denominators will stay the same. 3 times 7 is 21, plus 2 is 23. 2 times 14 is 28, plus 3 is 31. So we add 23 over 7, division becomes multiplication, and we have 14 over 31 because we have to take the reciprocal of the second fraction. Now the prime factorization, 23 is already prime. 14 becomes 2 times 7. Our denominator, this would be 7 times 31. We have one set of 7's that simplify out. 23 times 2 is 46, all over 31. Now we have an improper fraction here. Because we started out with mixed numbers here, we have to make this into a mixed number. So we would go off to the side, and we could take 31 into 46. 31 goes into 46 once. 1 times 31 is 31. 46 minus 31 is 15. So we have a remainder of 15. Now this is what we would do. We have 1 as our whole number. Our denominator would still stay 31. And our remainder is our numerator, which would be 15. So our final answer is 1/15 over 31. Now we come here to number 4. We'll put a 1 under this 3, and we add 3 over 1. Division becomes multiplication. We take the reciprocal of the second factor here, and now we will have 3 times 2 times 7, all over 1 times 3, we know is 3, and 3 is already prime. These 3's will simplify out. This will give you 14 over 1, which is 14. And we're done with that problem. Now we come to example set D. It says solve. A designer of clothing designs an outfit that requires 2.17 yards of materials. How many outfits can be made from 30-yard bolt of material? So you would take 30 divided by 2.17. So now we'll put 30 over 1, and we need to change this mixed number to an improper fraction. So it'd be 30 over 1 divided by, your denominator would stay 7, your numerator would be 15. So it'd be 30 over 1 times 7 over 15. So we take the prime factorization of 30, which is 2 times 3 times 5. And then we'll bring over our times 7. And our denominator, we'll have 3 times 5. These 3's and these 5's will simplify out, and you have 14 over 1, which would be 14. Now it'll be 14 outfits. And that is your final answer. Now we start at 3.6, adding and subtracting like fractions. Fractions with the same denominator are called like fractions. Fractions with different denominators are called unlike fractions.